Okay, today is just a continuation of yesterday, just going one step farther and looking at actually all the possibilities of bounces and squiggles, not just when it's squared and cubed. Okay, so let's talk about odd multiplicities. Now again, that's a word that in 3 months you may forget. Multiplicities, what was that? That means your degree, right? So if you look at these three graphs, x minus 2 cubed, x minus 2 to the fifth, and x minus 2 to the seventh, what do they all have in common? Can't hear you. Yes? They have the same 0. Okay? And what will they do at that 0? They will squiggle. Now the whole thing is, what's the difference between, let's look at these two, because we have to come up with a rule. Now, again, if you don't memorize the rule, you can figure this out pretty quick by putting it into your calculator and then reminding yourself. That is the slower route, but okay. So just put in x. I want everybody to do this. X minus 2, and we're going to cube it. Okay. Now in y2, let's make that the thicker one, or else we'll have no idea which is which when this thing graphs. And we'll go x minus 2, and we'll go to the 7th. We're going to do the last one there, okay? So we should be seeing a squiggle, and we should be seeing it at 2. Okay, there's the first one. There's the second one. So we're getting the same behavior there, but what's the difference? What would be a rule to write down on a study sheet? Is there any difference at all? How what? I would say that steepness increases with the higher degree, right? But they all do a point of inflection or squiggle at the same thing. Now, let's just kind of write this down. This one goes through here. Oops. Goes through 8. I want to do that a little better. Okay, so this was x minus 2 cubed. And it actually goes through -8, the y-intercept. If you do x minus 2 to the 7, it actually goes through point -128. So it's way down there. Okay, and then does this. So this would be x minus 2 to the 7. Okay, so I would say this one is steeper. Now it says what happens to the multiplicity of 0 through the odd as the number increases. We said the steepness will increase, but we do want to say that all graphs squiggle at point 2, 0. Now what is the technical name for squiggle? Point of inflection. Okay, so there's one more rule that you need to know. Again, by getting all your rules in one place, it really helps to study. It really helps to draw similarities, differences. You have to discern when you need to do things, when you don't need to do things. Okay? Now, what would you assume before even doing this one about okay, so if x minus 2 squared, what's happening at where? Okay, it would be happening at point 2, and I will get a, now remember this has a 50 as a, so it's doing something kind of like this. That is x minus 2 squared, and you should imagine that if we did graph x minus 2 to the 6, it would be steeper again. Okay, but what do they all have in common? I'm just going to write this as x minus 2 to the 6. What do they all have in common? All graphs bounce at point 2, 0. What is the technical name for bounce? Tangent. Okay, so here's kind of the rules. Everybody get all that? So here's all the rules, okay? If you have a real zero with even multiplicity, so that's 2, 4, 6, or 8. So x minus 2 to the 2, 4, 6, or 8. It will always be tangent to the x-axis. If you ever have odd multiplicity, it will always be a point of inflection. The bigger number just affects the steepness. So yesterday we just dealt with squared and cubed. Now we're going to say 2, 4, 6, 8, 10, 12, 14, 16, blah, blah. They all have the same, or they all will be tangent. So even will be always tangent, odd will always be point of inflection. Okay, that's what that rule states right there. Now, this asks for two things. They want to know the distinct zeros and the possible multiplications or possible multiplicities. Now, looking at 1, how many distinct zeros does it have? 2, right? 1, 2. Okay, so let's just write that down. For number 1, it would have 2 distinct zeros. Okay, now the second question it asks is, what would be the multiplicity at 1? 2, 4, 6, 8, 10, any of those, right? Now we don't know for sure which one it is. We can't assume 2 anymore because maybe it's steeper. Maybe that's 6. Okay, so at point 1, we would say that has 1 real zero of multiplicity 2 or 4 or 6, ... Okay? At point 2, there is also 1 real zero of multiplicity what's the multiplicity at point 2? Okay, you saw how I wrote the first one. What would the second one be? Right, 3 or 5 or 7, ... Can it be 1? So we don't want to say of odd multiplicity because would that not be wrong? Okay, so see how this one says odd multiplicity greater than 1? So this is very specific that it must be greater than 1 because 1 is straight through, right? Okay, now let's just talk about 2, 3, and 4. We don't have to write those down. How many distinct zeros are in 2? 3. 1, 2, 3. What's the degree here? 1. Degree here? 2, 4, or 6, or 8. We don't know for sure, right? And here? 1. Okay, let's do this one. How many distinct zeros? 3, right? What's the multiplicity here? 2, 4, 6. Multiplicity here? 2, 4, 6. Multiplicity here? 1. Okay, how many distinct zeros are here? 3. Multiplicity here? 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 3, 5, 7. Okay? You get it? Okay, let's go to let's do this one here. Now, without a graphing calculator, make a rough sketch of this graph. Now, I know what you're thinking. You're like, well, if this was on the diploma, I would just graph that. Okay? That's good, but maybe you're not like me, but maybe you put it in the calculator wrong. Should you not kind of have an idea in your mind what it should look like as you're drawing it? Okay? Whenever you're buying stuff and you're going to the till, you need to have an idea in your mind of how much it's going to cost. You must have that, right? You just can't, oh, that's cool, okay, whatever, right? Because maybe you thought it's on sale when you're looking at it and you get up there, you better hope that that's coming up on the computer, right? So the same thing when you're doing this. This is what this last 3 is about, is can you think about it before? Because I think a lot of people just go an equation, picture, I'm not always getting whatever, not getting the connection there, but I'm sure it's right. Okay? Now this one here, what would be the degree if I multiplied all those out? It would be x to the 6. Now, would this be a positive x to the 6 graph or negative x to the 6? This is a negative x to the 6 graph. Does everybody see that? Where does a negative x to the 6 start? 3. Good. It'll start here, and where will it end or finish? 4. Now, what I like about something like this, they could have just said negative x, x minus b to the 4, x minus c. That's it. Asked you, which possibility could this graph be? And you have to, they're going to have 4 graphs there. Now, going left to right, what are the zeros? What are the zeros? 0. Don't forget about that one. Some people are, and they did that on their quiz. The next one, 1, and the next one, 4. Now, I'm going to help you with that part. I want everybody now to draw the graph. Now, the highs and the lows, I'm not concerned about, obviously, but can you do this graph? I've given you most of the stuff to do this. Okay, so you should start from here, and you can see you will end in the right spot if you do everything right. If you're ending in the wrong quadrant, you either counted the numbers wrong, because you should have counted, there's a 1 there and a 1 there, so there's 4 of these, right? you guys know that's the efficient way of writing x minus 1 times x minus 1 times x minus 1 times x minus 1. So there is 4 x's there. And then we've got the 1x in the front and that other x with the minus 4. So there is 6 as a negative. I am starting in the right place. I need to go through here. Now, how am I supposed to get back to 1 is obviously I've got to turn. Now, I'm not really concerned about where. And I've got to bounce. And it is a pretty big, it's to the 4th, right? So it should be kind of steep. So to come up steep, this one would actually have to be maybe a bit higher to pull that off. So everybody would have that graph. Now maybe your highs and your lows aren't there, but did you bounce at 1 and go through 0 and 4? And do you see how, put your arrows on both sides, because it actually is going, we say starts there, it doesn't really start there, okay? It's been infinitely coming that way up, and then, but that's the best way to be able to. Okay? Next one. Let's do A and B. Now, just by looking at this, this is a great question. It's nice and easy if you studied, and it's impossible if you didn't. This one just says state the degree of each polynomial, and you're looking at a picture, like how are you supposed to do that? Okay? Now it asked that x, p of x, they must be always the lowest possible degree. So what is the lowest possible degree at A? X to the 2. Good. How about at D? So x to the 1 and F? X to the 1. So what is the lowest possible degree of this function? No, of the entire function that made that graph. 4. Right? We got x to the 2, x to the 1, x to the 1. That would be x to the 4. So 4 is the lowest possible degree of the entire polynomial. Not, they didn't ask what was the lowest degree within it that made it up. Now, which point on that graph would represent real and equal roots? Where there does it have real and equal roots? Okay, both A, D, and F all have real roots. Which point has 2 identical ones? A, right? So these equal roots means identical roots, right? So the second part of that would be A, because A is like probably x plus 6, x plus 6. That's what's going on at A, which is x plus 6 squared. Okay, look at B. What is the lowest possible degree that could make that happen at P? 3. So that's an x to the 3 at S, x to the 3. So what is the lowest possible polynomial that can make that? X to the 6, right? Or degree 6. Okay, which point or points has equal and real roots? P and S, right? Because maybe that at P, that's like an x plus 6, x plus 6, x plus 6. And at S could be x minus 6, x minus 6, x minus. Those are real and equal. Okay? Now, example 4. Both of these, again, are really good questions because you need to know your stuff to be able to do them, and your calculator can't save you. And for me, I would just write this as the question, and then I'd have 4 graphs. Pick which one it is. Okay? So which graph would have a positive leading coefficient? Which one would represent a 0, 1 0 multiplicity 1, 2 zeros of multiplicity 2, and 1 0 of multiplicity 5? Okay. Now, can anybody tell me what the degree of this polynomial will be. Okay, 8 is the one they would love you to pick if you didn't know what you were doing. Okay, so I hear a 10. Does 10 make sense? Okay, one real zero of multiplicity 1. Let's just write that down. That would be an x to the 1, right? We have two real zeros of multiplicity 2. So that's followed by an x squared and then an x squared. Okay, and one real zero of multiplicity 5. That would be x to the 5. So do you see how we would have an x times x squared times x squared times x to the 5, which would give me a x to the 10, right? Okay, now let's draw this. And we'll draw it in the order they gave it to us. If I was to do it in a multiple choice, I could mix up that order. Doesn't matter. You will still come up with the same start and finish. You won't come up with the same looking graph, but I want you to do this in order. See if you could draw this graph. Okay, I'm going to give you a minute to see if you could draw the graph. And you really have to think. You need to know all of the last two lessons to be able to draw this one. Just because it's technology. Okay, now try. Okay. Weird. It's not working. Always works for me. Okay, now you're on. Okay, see if yours looks like this. Nice. Okay, so you should get the idea there. Now, okay, so with this, let's see. I'm going through, so that's my x. Then I got an x squared, I got an x squared, and I got an x to the fifth. Because it is positive, you should be starting in 2 and ending in 1. Okay? So one more, and then I'm going to pick somebody to do that one. This time, hopefully, I'll have the... Okay, so went through first. So here we have an x, then another x because it says 2 real. Okay, then went up, and then I've got multiplicity 3 here, and then another bounce multiplicity of 4. It is a negative. You should have had a total of 1, 2, 5. You should have an x to the 9, right? Okay, does this make sense? Yep. Okay, so here you go. I spent all this time writing the homework, and I go, oh, that was the homework. Okay, so you're doing 1 to 5, 8, and 9. Okay, I'm not doing these notes. Just go right to the assignment. Okay, guys, don't waste this time. Let's go. Everybody should get done in class today.